Good morning, everyone present here. Let me introduce myself to you. My name is E. Avna Choprigod and I am from CSMA. Today, I am going to talk about understanding Bayesian classification from the subject machine learning. Introduction to Bayesian classification. What is a Bayesian classification? Bayesian classification is a statistical method that applies Bayesian theorem to classify different data into different categories. It utilizes prior knowledge along with evidence to infer the probability of each category being correct. The concept of Bayesian classification dates back to the 18th century, attributed to Thomas Bayes. This implementation in machine learning gained momentum in the late 20th century, particularly due to the advent of computational power. The applications of the Bayesian methods include various fields like spam detection, sentimental analysis, medical diagnosis, and image recognition. Now we are going to talk about Bayesian theorem. Bayes' theorem describes the relation between the conditional probabilities of events. It provides a mathematical framework of updating the probability estimate of hypotheses as more evidence is required. The theorem is expressed as P of H by E equals to P of E by H into P of H by P of E, where H represents the hypothesis and E signifies the evidence. Period and posterior probabilities. In Bayesian classification, period probability reflects our initial belief about hypothesis before observing the evidence, and the posterior probability, on the other hand, is the updated belief that incorporating the new evidence. The transition from the period to posterior allows for continuous learning in classification tasks. The evidence in the Bayesian classification. The evidence in the Bayesian classification refers to the data or signals that influences the assessment of various hypotheses. It plays a crucial role in determining the livelihood of the observing evidence given different hypotheses. And types, we are going to talk about types of Bayesian classifiers. The first one is Navier Bayes classifier. It is a simple and yet effective probabilistic classification model based on applying Bayes' theorem with a strong independence assumptions between the features. It's commonly used in text classification tasks such as spam detection and sentimental analysis due to its efficiency and scalability. And the next one we are going to talk about is Gaussian Naive Bayes. Gaussian Naive Bayes is a variant of Naive Bayes classifier that assumes that features follow a normal distribution. It is particularly suited for continuous data and works well when the assumption of feature independence holds true. This model estimates the mean and variance for each feature for, and the next one is multinomial naive Bayes. Multinomial naive Bayes is a design for multi-class classification problems and works well with discrete data such as what counts in text classification. It estimates the probabilities of each class based on the frequency of feature occurrences. This is commonly used in document classification tasks. And the key concepts of this is likelihood function. In Bayesian classification, the likelihood function quantifies how the probability the observed data is under different hypotheses. It is a critical component of Bayes' theorem, helping the update prior beliefs into posterior probabilities. The formulation of likelihood varies depending on the model being used. And the next one is model evaluation metrics. Evaluating the performance of software, Bayesian classifier involves several metrics such as accuracy, precision, recall, and F1 score. These metrics help assess how well the model classifies data and provide insight into potential improvements. Additionally, ROC curves and AOC can be used to visualize the performance. And we are going to discuss about overfitting versus underfitting. Overfitting occurs when a model learns noise in training data too well, resulting in poor generalization to new data. In contrast, underfitting happens when a model is too simple to capture the underlying trends Striking a balance between complexity and simplicity is crucial for effective Bayesian classification. Visualizing Bayesian classification. We visualize these by graphs and diagrams. These visualizations play a vital role in understanding Bayesian classification. And the next one is decision boundaries. Represent the regions in feature space where the model classifies the data points into different classes. These impact feature relationship on classification outcomes. And conclusion. In summary, Bayesian classification techniques offer a robust framework for making the probabilistic predictions across various domains. Understanding the types of classifiers, key concepts, and effective visualization enhances the ability to deploy these methods effectively. And thank you everyone for giving me this wonderful opportunity. Have a nice day ahead.